Hello everyone, my name is Raul Gutierrez, and today I will be talking about the pharmacology of nicotinic acetylcholine receptors. So the reason I will be talking about the pharmacology of nicotinic acetylcholine receptors is because Dr. Brenner and his team at UT Health San Antonio have found that ziquilinium blocks muscarinic receptors, and if ziquilinium can block both nicotinic and muscarinic receptors, this could provide for potential treatment for organophosphate toxicity. Every year, there are about 3 million people worldwide that are overexposed to organophosphates. Out of those 3 million, there is about 300,000 deaths due to organophosphate toxicity. How organophosphate toxicity works is that organophosphates are acetylcholinesterase inhibitors. Because they're acetylcholinesterase inhibitors, they increase acetylcholine in the synaptic cleft, and the increase of acetylcholine in the synaptic cleft causes overstimulation of acetylcholine receptors, causing signs and symptoms of organophosphate poisoning. Organophosphate poisoning happens from occupational exposure or accident exposure. Organophosphates are found in insecticides, pesticides, industrial chemicals, or chemical weapons. And here's a cartoon how it works. There's a presynaptic neuron, postsynaptic neuron, a ton of acetylcholine, synaptic cleft, acetylcholine receptors, and there's just a large overstimulation. Here's the acetylcholinesterase inhibitor, the organophosphate, killing the acetylcholinesterase. Symptoms of this organophosphate toxicity is increased saliva, tear production, vomiting, small pupils, sweating, muscle tremors, and confusion. So cholinergic receptors, there are two types: nicotinic receptors and muscarinic receptors. Nicotinic receptors are a group of cholinergic receptors linked to ion channels in the cell membrane. There's two types, N1 and N2. They're excitatory receptors. N1 receptors are located in the neuromuscular junctions. N2 receptors are located in the brain, autonomic, and parasympathetic nervous system. They mediate fast synaptic transmission of nerve impulses, and hence the name nicotinic, respond to nicotine. Muscarinic receptors are a group of G protein coupled cholinergic receptors that phosphorylate second messengers. There's 5 types: M1, M2, M3, M4, and 5. M1, M2, and 5 are excitatory receptors, while M3 and 4 are inhibitory receptors. And they're found in the brain, heart, and smooth muscles. They mediate a slow metabolic response via second messenger cascades, and hence the name muscarinic, respond to muscarine. So here's an image of nicotinic receptors and muscarinic receptors. Here, what these signify is that the threshold for a nicotinic response from acetylcholine is 100 micromolar to the millimolar range, and for a muscarinic response, you need 10 nanomolar to 10 micromolar of acetylcholine, which is a lot lower than nicotinic, and this will be important in the experiments that I show, because there will be also muscarinic receptors present in some of these experiments, unfortunately. And some antagonists that we use during the experiments is MG64, that is for nicotinic, and 4-DAMP, which is antagonist for muscarinic. So the question here is, how do we screen for new cholinergic receptor antagonists? And that takes us to the method summary. So we used a plasmid. Dr. Brenner and his team has a plasmid shown right here. So this part right here, the PEF1 alpha, is the promoter, drives the expression, the alpha 7 nicotinic acetylcholine receptor, that's the receptor that we use, the alpha 7 specifically. Iris, internal ribosome intersite. Nacho is the receptor chaperone protein. CMV, cherry, is a fluorescent protein. cDNA to identify transfected cells. So this is how we differentiate which cells had alpha 7 nicotinic acetylcholine receptors and which cells didn't. We use confocal microscopy to capture the fluorescence intensity of cells. So when we applied acetylcholine to a cell, this would cause a fluorescence, and the confocal microscopy software would capture it, and it can be measured. Patch clamp experiment was done by Dr. Gay. I'll explain why patch clamp was done later, but that was done by Dr. Begay. And we use a dye called Calbright 520 AM. And how the dye works is that when acetylcholine would bind to the receptor, it would open the channel and calcium would flow in. And when calcium flows in, it binds to the Calbright 520 AM and it causes fluorescence. And so that's what was being measured, the fluorescence in the cells. Okay, so excuse me. Make this a little bit. So nicotinic acetylcholine receptors, there's a response shown here, but this is only with PNU. So PNU is a positive allosteric modulator shown here for alpha 7 nicotinic acetylcholine receptors. Basically, it holds the receptor open and we were able to see the response. Here we show that 500 micromolar of acetylcholine is given to the cells. There's no response, but they have 500 micromolar and 10 micromolar of PNU. We see a large response. So this is good, but the goal of this project is that we want to create an effective assay to study alpha 7 nicotinic acetylcholine receptors in the presence of PNU. And that's the goal, because we already have data showing that diquilinium blocks alpha 7 nicotinic acetylcholine receptors with PNU, but we want to do it without PNU. And here in the back is actually HEK cells. This is how they look like when they are fluorescent. So add a picture. And here, HEK293B6 cell line demonstrates small transient response without PNU. So here, there's no PNU used in this HEK293B6 cell line. And we see that 100 micromolar of acetylcholine applied twice, there's about a similar response that was seen. And so we wanted to make sure that there was no muscarinic response. So we used 4-DAMP, which is a muscarinic antagonist. And we applied 500 micromolar of acetylcholine. And then we applied 100 nanomolar of 4-DAMP and 500 micromolar of acetylcholine. And unfortunately, we saw that there was no response. So that indicates that there's endogenous muscarinic receptors. So this shows that the response was due to endogenous muscarinic receptors. So that's a problem, because now we're wondering, is there nicotinic receptors at all? So we do another experiment we apply 1 micromolar of Mg6204 to all the solutions. So this means that basically all cells will have the antagonist, the nicotinic antagonist, so there should be no nicotinic response at all. And basically what we find is that 21% of HEK293 FT responded to 10 micromolar of acetylcholine. So this is all due to muscarinic receptors. And to make sure, we also applied 100 nanomolar 4-DAMP and 10 micromolar acetylcholine, saw no response. As I said before, 100 nanomolar, or as I said, 4-DAMP is a muscarinic receptor, so this was a muscarinic response, and then 4-DAMP blocks the muscarinic response right there. So we weren't sure if there was actually any nicotinic receptors, so Dr. Bagay performs a patch clamp, and he proves that there is nicotinic receptors present, as shown here in these HK293 B6 cells. So our hypothesis on why we could not see the response of nicotinic receptors is because when the calcium would flow in after the acetylcholine bound to the receptor, it would just flow out, so it wouldn't really hit the cowbright very well. And so our solution to that was that we got a plasmid from Tobias Meyer, and basically the CAX signals the protein to be attached to the plasma membrane. The GCAMP signals the GCAMP to be attached to the plasma membrane, as shown here. And basically what would happen now is that the calcium will flow in and go straight towards that GCAMP, and it would provide a fluorescence. So we would be able to see it. So it would essentially provide a lot quicker, so we could actually see the fluorescence instead of it just dying off very quickly, just spreading throughout the entire cell. So what we do here is that we use the GCAMP, and basically we apply, so we transfect cells with this plasmid, and we run this experiment where we apply 100 nanomolar 4-DAMP and 500 micromolar acetylcholine, and we see a response the first time, and then we see a response the second time, slightly lower response the second time, and that is due to desensitization of alpha-7 nicotinic acetylcholine cells. But we were able to get a response. And conclusions for my experiments were that nicotinic acetylcholine receptors are difficult to image using conventional organic calcium dyes. HEK293 FT cells may have other types of muscarinic receptors that may be interfering with assaying the nicotinic response. Membrane-tethered calcium indicators like GCAMP can sense calcium influx through nicotinic receptors. And so those were my conclusions for my experiments, and that is it for my presentation. But I would like to most importantly thank Dr. Brenner, Dr. Vlad Bagay, Matthew Belanger, Summer Gregory, and the SPUR program at UT Health San Antonio. And I would like to thank everyone here for giving me your attention. Thank you.